This is ESG Decoded, the podcast powered by Global Affairs Associates to provide relevant, actionable updates related to business innovation and sustainability. Join Caitlin Allen and Amanda Hsieh of Global Affairs Associates for thoughtful, nuanced conversations with industry leaders that explore the complexities, the risks, and the opportunities connected to all things ESG. I'm Yvonne Harris, a consultant and co-host, and I will be collaborating with Caitlin and Amanda for the discussions that we will present on this podcast. Put simply, ESG is everything that is not on your balance sheet. This leaves room for misunderstanding, oversimplification, and the tendency towards one-size-fits-all perspectives. None of that will happen on this podcast. Enjoy this episode.
This is Amanda Hsieh of Global Affairs Associates, and today we have Paige Marie Morse, who's the Industry Marketing Director for Chemicals at Aspen Technology. Aspen Technology embeds artificial intelligence throughout industrial manufacturing environments and helps the world's largest oil and gas, chemical, and engineering companies achieve their safety, sustainability, and operational performance goals. Paige has worked with leading operating companies, including Shell, Dow, Sunoco, Clariant, and many more in R&D, marketing, commercial, and strategy roles. Paige, thank you so much for joining us today on ESG Decoded.
Thank you. Nice to be here.
Paige, you're at the very interesting intersection of two very hot topics, AI and sustainability. So I'm very excited to dig into these topics with you today.
You're right. It's an interesting area, actually. And what we're finding is AI actually is a huge benefit towards sustainability. So we can talk more about that today.
Let's jump right in. How is industrial AI being used to help companies achieve their sustainability or ESG goals?
Yeah, okay. So let me just give some context first, right? So the idea of using technology and AI in oil and gas operations, chemical operations, or making plastics for that matter. The way you use them is it's software that helps you run your plant better. And so most of the time it's a software capability that helps smooth out the operations. So the first thing you think of there is, okay, smoother operations, it means it's safer. So it's safer for the operators for sure. And then maybe even you can use software to help you see if there's an operating issue that's coming and you get warning so you don't have a safety incident that maybe, again, could be an issue for operators or it could be an issue to the environment. So software is helping you there to avoid a problem. But the best use of it is how to optimize and run the best possible way. And most of the time when people use software, they think, okay, I want to smooth my operations, use something called process control. But they did it for financial reasons. Of course, they're pushing for margin. You want to get as much out of your refinery or your ethylene plant or your plastics unit as much as you could. And it was often driven by financial. And what we're finding right now is we're still using that same software, but instead they're saying, actually, I want to run and use less energy, or I want to run and be sure I don't make as much waste between each of the different plastic products that I make. How can I change the way I operate? And that's a really important shift that we're seeing literally just in the past few years, and certainly varies a little bit from one geography to the next too, as to how important it is. But that's really where technology is helping.
I think I see the direct connections to continuous improvement methodologies such as Six Sigma or lean manufacturing. And what I'm understanding is that AI is basically helping us to understand the data or process the data maybe faster, deeper than humans can.
Right. Yeah, exactly. And in fact, we take the concept of AI and we actually call it industrial AI. And what we mean by that is we're taking all the learning capability that's possible with artificial intelligence, where you take previous experience and figure out what the story is and what the lessons were, and now apply it to the future. But what's important when you do that, you put it in the industrial context. What's feasible in a refinery? what's possible in the plastics production that you're doing, and make sure that you use the AI within that box. That's what's critical. And that's the idea of industrial AI. You take the context and the knowledge of the environment, and then you take those lessons and put it on top. So I'll give you an example of how you use that is, many people have been running these plants for years, right? And so they have been collecting data about operations and what works best. Well, now you can take all that data and figure out what the story is, what works best on those assets, and give that feedback back to your operator. It's particularly valuable right now when we're going through this generational change. You know, we've been talking about it, people are retiring and you're bringing in young, newer operators. Well, if you can give them some guidance about what's happened before and maybe how to manage this situation right now, because it's new to them, you're smoothing operations, and again, maybe avoiding an incident that could be a little bit scary, but mostly it's about, I'm very smooth, I know how to handle this situation, and I get guidance from my software. In fact, my software's telling me, hey, by the way, right now you should turn this down or do that. And again, let's put that in the sustainability context. Used to be all about profitability. Now it's saying, listen, you actually don't need to crank the temperature so high right now. Pull back a little bit. And that, of course, translates directly to less energy used, less CO2 emitted, and other emissions, of course, that go with operations. So there's all these new metrics that we can use to watch. And our tech tools, our AI, give us this visibility on what the impact is from what we do at our operations to what these emissions are. So we can make some adjustments and give it overall a better outcome for the environment.
But I also think about is just how much more efficient we can be in our operations. And I remember when I was working and visiting a lot of factories, and a lot of the managers always talked about how, the low-hanging fruit's pretty easy to grab. It's when you're going further and further, and it's that last 5 to 10% that he actually gets almost exponentially harder to grasp.
That's definitely true, and we've seen that in a lot of the projects, because early on, a lot of the projects were targeted at, let's get the cost down quickly, this low-hanging fruit, quick energy adjustments. So one of the things people are looking at now too is, if I want to think about CO2 emissions, maybe I just used to get utilities from the coal-fired power plant down the road. Well, wait, what if I rethink that and try to access the windmill capability that I could get? That now, it's scope 2 emissions, but you're still bringing down emissions related to your operations. And so people are making those kind of decisions as well. But, in that idea of low-hanging fruit as well, I've also been talking about existing assets. A huge part of sustainability right now is the future. Where are we headed? So I think I'll just describe it the way we talk about it at Aspen Tech. We put it kind of in 3 buckets when we look at sustainability. We first look at resource efficiency. And there, I mean, obviously energy, like we've been talking about. Feedstock, of course, you don't want to waste your feedstock and make something that's not valuable, ultimately ends up as waste. And then you just want to keep all the effluents down from your plant. Could be water use as well. So, but that's current assets. A lot of us are focused there. Of course, that's important. But these days, everyone's talking about these long-term goals. Where are we going to be in 2030? Maybe we'll be net zero in 2050. Well, you know what? That is a completely new way to do things. You can't just make it a little better with energy, save 10% here. You actually need to completely rethink what you're doing. So maybe I should shift to hydrogen or ammonia as an energy source. How is that going to work? Or these days for plastics, how do I take the plastics apart and maybe use them as waste or to make new plastics, completely new areas? Those are the bigger problems. And we put those kind of in the long-term buckets. The most common way people refer to them is the energy transition, changing now. Maybe I'm not going to use crude-based fuel products anymore. I'm going to use something else. Or we talk about the circular economy, which is now how do I think about the products that we all use every day and not have them ever go to the landfill? Turn them around and turn them into the next product or into energy, but it just turn them into something else. People are also using technology there in the redesign of new products or how to figure out the best way to deliver hydrogen to communities if you decide that's going to be your energy source, or the best way to channel all that windmill energy into the cities and large areas of use. Technology is so important there. And AI just makes that even better and more efficient each time.
There's, of course, the existing infrastructure, but I think you highlighted something interesting also about the design of new and designing perhaps for disassembly and being able to reuse, recycle, and be part of the circular economy and not, have a useful end of its life. Tell me more about that. That's a really interesting topic.
Yeah, that's circular economy is a huge challenge right now. And I know probably most people are familiar with the Ellen MacArthur Foundation that has a lot of materials on this topic. And it's a big issue for chemical companies, particularly because right now they're making products that end up maybe as the pieces of our cell phone. But when you're done with that, where does it go? How do you take it apart? We don't have a good way to do that. So what people are doing is they're redesigning now. How can I make the performance that you expect as a consumer, but deliver it to you in a way that I can then turn it around and put it back into the economy? So it's a long-term discussion. What's really cool, and I'll tell you, it's interesting to be part of this, is it's also across the value chain, because often a chemical company or a refiner or a plastics company is in the middle of the value chain. They have all these pieces along the way, and you've got the consumer way out at the end. Everybody needs to be talking to resolve what these issues are, because we're doing full redesign. And so those conversations, that collaboration is so important right now. And again, I'll just reference back, technology helps that because, okay, let's share databases. Let's start with the basics. I'll tell you, Aspen Technology is with many other companies as part of the Alliance to End Plastic Waste. And they're putting together huge databases of new technologies that people are using, things that we're learning in different regions that we could apply to a different part of the world. We need to do that kind of thing where we get together and solve these big problems. So to me, this collaboration across the value chain to fundamentally redesign either the product or the energy systems, that's an exciting area to be in right now.
That's very exciting. I totally agree. I think what you said about having that systems thinking and needing the different players in this circular system, talking, collaborating, communicating is so important. I think it's really interesting how digital technology or AI can just help us all see the insights or hopefully faster and find the solution faster. And your example earlier with plastics or chemicals, I think is really interesting because I don't think most of us think about how many different types of plastics and potential additives and kind of the recipe that can be used that to achieve different characteristics for that plastic. And I think it's a really interesting challenge to get the desired characteristics, but also think about already how can it be reused later on as a input for something else.
Yeah, exactly. And, I think everyone's suddenly alert to plastic in a way that they weren't as much just a few years ago, which is great. We should be paying attention to our environment. One of the things about plastic that's interesting, though, is obviously it's lightweight and it floats. So unfortunately, it gets blown around if you don't take care of putting it into trash, or it floats in waterways and it ends up causing a big problem. So we have this great awareness. But trying to resolve this is actually not very easy. I think everyone wants to jump in, which is great, but I think we also need to acknowledge that it's a big challenge. So I'll just give you an example. You brought up the different types of plastics. I think many of us have begun to learn about the numbers on the bottom. There's number 1 through 7 typically, and number 1, PET, is probably the most recycled. But the most common way to do that, though, has been to melt it down and then use it for something less valuable. Could be the lining of your car trunk, for example, or a park bench or things like that. They end up as less valuable when they started. That is fine. You can do some things with that, but particularly the other plastics have a lot more additives. Think about how brightly colored some of your personal care products and detergents are at home. That plastic is not the simple material that came out of the plastics company production unit. It's got all these additives in it. So now how do we work with that to make another material? So it's difficult. What we're finding is one of the cool ways to do it now, though, is instead of just melting it down, which is called mechanical recycling, you cut it up and you just melt it and make a new shape or make a fiber. What you need to do now is actually take the molecule apart, because there's so many different types of materials mixed together. You got to take it apart and then reuse the material that you've made by taking the plastic apart to again make more plastics, or an energy source or something else. And that's generally being called these days advanced recycling. So it's kind of the next step. There's a lot of cool chemistry and engineering involved in that. And this, again, the Alliance to End Plastic Waste is getting very involved in that topic. And you'll see a lot of the major plastics producers and even the big brand companies like Procter & Gamble and Colgate and whatever, they're all getting involved in this too, because they're saying, hey, consumer, I want to give you that plastic container that now has recycled content in it. But they got to figure out how to do that. So again, we're back to value chain collaboration. How do we resolve this? And these days, it's looking like it's going to be cool chemistry that's going to make that work. But it'll take us a while to figure all that out. And again, though, let me just go back to the technology angle. You can now model those processes and figure out what's the best way to build a unit to do this, advanced recycling, and how to scale up. That's a big challenge right now. We've got to let cool little guys making small things, but we need to do it bigger. Well, the best way to start looking at that is build a model, let's do it by simulation and see how well it works. And then you can start to actually build the unit, the much larger scale that you need. So yeah, technology is right in there, and AI giving insight on performance properties and that kind of thing to feed back is to tell you what kind of composition would work well. That's what we're learning as well through all of this process.
I think that's just really amazing and sounds almost sci-fi-ish.
Yeah, kind of cool. But okay, forgive me, I'm a chemist at heart. I can't help it. I'm going to go back to the cool molecule stuff, even though we need to all be able to tell our stories to the rest of the world. But come on, the chemistry's still cool. I can't help that.
That's very cool. And I think this idea of being able to simulate and model, and before you actually scale up, or just to see what will happen when you scale up, or how will this kind of new combination or recipe or whatever it is, how it will perform in reality. I think that's very powerful too.
Yeah, one of the things too, it really helps speed, because it used to be that if you have to try everything in the lab, test each one of them, that takes a long time, years to develop a new product. Now, if you can simulate it and say, well, if I try it like this, okay, I think the properties would look like this. Again, using AI to give you feedback on performance, you can make the decisions faster and have to do less experiments. Some people call this in silico experimentation, which means you're doing the simulation in the computer, but it guides what you end up doing in big production. And we need speed, right? Let's think about it. We've got goals, 2025 in Europe, 2030 for sure, 2050, that's not that far away. We need to get moving on some of these big problems. So any kind of thing to accelerate that is important.
You previously mentioned the Alliance to End Plastic Waste. Will you tell us more about that?
Oh, it's a great idea. What's cool, again, it's back to the value chain. You've got brand companies involved. You've got waste management companies involved, and certainly the plastics producers. So all of the majors like Dow and Lyondell and Exxon, and Sabic, all these big companies are involved, and they're trying to find solutions to this challenge. One of them is this advanced recycling, as I mentioned, but they're also doing things like sponsoring cleanup activities and sorting activities in communities around the world. And they're actually based in Singapore, because as I think we know, some of our biggest challenges in terms of waste leakage into the environment is in that region, although it does certainly happen everywhere, but they very much focused in Asia. The other thing about Asia too is huge growth expected. We already it's the biggest area for plastics production, but it's also huge demand as well. So we really they've been more focused in that direction on some of their cities projects. They've got some cool things going on in Indonesia and the Philippines, looking at some challenges in India, of course, as well. But back in this region, we are also doing things for example, in Latin America, North America, and Europe, a lot of cleanup activities. One of our challenges too is to make our recycling better. Think about what you collect at your own home. How will we be sure that we're getting all the materials into the bin? And then what are we doing about separation and trying to get it to these advanced recycling or mechanical recycling processing plants? We're still not very good at that in this part of the world. We got some work to do there. So that's one of the things they're doing as well.
I agree. We have single source recycling where I am, but sometimes it's still hard, even if it's single stream recycling. But sometimes it's still hard to make sure the recyclables go in the recycling bin and not in the waste bin, let's say.
Exactly. Yep. So I think work to be done. Something we all need to be working on this, in my view. So.
And I think what else is interesting about the alliances they're trying to tackle on kind of multiple fronts too. We think a lot, I think about like the beach cleanups and the waste collection part, but I think we forget that in some parts of the world, there's not an established recycling system.
Yeah, that's right.
Infrastructure like we do here. Or waste management, maybe more broadly. So I think it's interesting that's from the producer side and all the way through.
Yeah, it is. And there's a big effort in a city's effort with the Alliance. And there's also one of the other things they're doing too is design for recycling. Think about all of the cool marketing that says maybe we want this very fancy package, but if it's got metal in it and 3 types of plastic, how in the world do you recycle that? Do we need to go that far? So this whole idea of design for recycling is also a big concept. And it really, again, it's back to the value chain side, getting the brand owners involved to say, do you really need to make it that detailed? Maybe we'll be fine with something that's a little less brightly colored, but it still works for the purpose. And so I think we need to be thinking that way as well.
I remember when I used to work at IKEA, and that was one of our the questions that we were trying to address and solve basically was design for disassembly. Especially for our European customers first, but also for our American customers as well. And it's an interesting challenge, but especially when you have mixed materials, as in your example, metals and plastics and how they're connected or bonded or glued together and or not. So it's a very interesting design challenge. And I could see how if something, industrial AI could help speed up that kind of challenge, figuring out the solution to the challenge.
And I'll tell you, well, we're just beginning to try to address this. And one thing that's cool, though, is that as part of the Alliance, they have funding available to a lot of startup companies around the world. And each of these different groups do requests for proposals globally to get companies to come in and say, hey, I've got this cool idea. Can I get some funding? Ideas are amazing. It's so cool to see that because people can be very creative. You give them a good challenge. It's wonderful to see the innovation and how it emerges. So I remain optimistic that we'll find a solution because there's just people that want to get involved and use their cleverness to resolve some of this. So Alliance is just an example. There's a lot of other groups who do this as well, but to encourage that innovation, I think is so important as we try to address things, like this and how we use materials differently and think about energy differently as well.
And something cool that your company did recently was Optimize 2021. Will you share some of the cool kind of highlights?
Yeah, because one of the things is really cool is that, so this idea of getting together and sharing your successes, share innovation. So every 2 years, Aspen Tech does this huge event for executives and managers and users who use our products within the process industry. So mostly it's energy, chemical, plastics, engineering and construction companies, but also metals and mining and pharma. And people get together and share their stories. And we just did it virtually, first time we've ever done it like that. But of course, what does that mean? People from all over the world can join us. And it's many more people than we would normally get. Usually, it's around 1,000 here in Houston. We got many more than that this time. And so everywhere around the world. And people were just as excited. Oh my gosh. In fact, so many people wanted to tell their stories that we couldn't all fit it in the time that we planned. So that's a wonderful response to say, all this stuff is happening. And of course, sustainability was a huge focus because it's urgent to companies around the world. And we want to share ideas on, hey, what our metrics are. It's not just about CO2, but what about percent recycling or an overall energy dashboard? So we had a lot of cool stories. So as I say, energy dashboard, that was done by a Middle East company called Sabic, huge chemical company, but based in the Middle East. They have an energy dashboard that they're developing. Really cool example of AI, actually, of a company using a modeling capability with AI input to improve the energy use in heat exchangers. I mean, the application happened to be a refinery, but every production unit uses heat exchangers. So this is a wonderful application, but they're eager to tell their story. And it's just so nice to see that. And then we've got some really cool things related to advanced recycling that are coming along as well. And we heard about some of those as also, because one of the sessions that I led is on circular economy. And so companies globally from Braskem, Nova, coming in and talking about what they're working on. And Sabic joined us as well. So there's a lot of big issues that people are working on, and digital has been a real enabler for them to make progress.
If people missed out on watching the live sessions, is there a way to watch recordings or replays?
Yes, so we got that. That's continuing now. The replays will continue till the end of June. So yes, okay. Still possible. And if you go to optimize2021.com, that's where you can see the full agenda and everything. And if you weren't already registered, you can go in and register and get to see the materials. But lots of great content, because everyone's wanting to be as efficient as possible right now. And digital is really, and using technology and AI is really a big part of that.
And I would definitely want to check out the session that you led about circular economy, just because that's a topic that's near and dear to my heart.
Thank you. Appreciate that. Yeah.
Well, Paige, I want to thank you so much for joining us today on ESG Decoded. Really love the conversation. What I appreciate too is that there is so much happening that yes, it's a big problem. And the good thing is that, there are many players, all throughout the value chain trying to do something. And again, I think it's only through this kind of collaborative work that we're going to solve this very, very big problem. If people want to follow up or connect with you, what's the easiest way to do that?
Oh, yeah. Hey, look for me on LinkedIn. Paige Marie Morse, certainly reach out there. I do a lot of posts on this topic. I mean, sustainability is so important, circular economy aspects. I really get involved in a lot of that. So yes, let's connect. That would be great. I'd love to have more dialogue on the topic.
Awesome. Thanks, Paige.
Great. Thank you.
Thank you for listening to ESG Decoded. Subscribe to this podcast wherever you consume yours, and follow ESG Decoded and Global Affairs Associates across social media platforms. Until our next episode, take what you learned today to drive long-term value for your organization by doing good for people and for the planet.